Boom. Okay, so here is the new set of notes. We have scientific notation and the metric system. All right, so first we will start off with scientific notation. We want to take a given number and put in a scientific notation, and then we want to take scientific notation and move the decimal out to get a decimal number or a whole number. Okay, so if you've never seen scientific notation before, then it looks something like this. You will have a number. So it'll be a number times 10 to a either positive or negative exponent. So some number times 10 to the positive n or the negative n. And this number, in order to put any number into scientific notation, this number right here has to be between 1 and 10. So whatever number we have to convert into scientific notation, it must be between 1 and 10. Can't be less than 1, can't be greater than 10. Okay, so let's go ahead and try it out on the examples below. So number 1 says convert 35,400,000 to scientific notation. So here's what we're going to do. We're going to put a decimal at the end of this number, and I'm going to move the decimal to the left until I get a number in between 1 and 10. So that's going to be 1, 2, 3, 4, 5, 6, and 7 spaces. So when I convert 35,400,000 to scientific notation, it becomes 3.54 times 10. And since we move this decimal 7 places, it's going to be times 10 to the 7th power. And the reason I write a positive 7 is because if it's positive, that means if we were going to convert this number back, we would move that decimal 7 spaces to the right. So if it's a positive exponent, you move that decimal to the right. If it's a negative exponent, you move that decimal to the left. Okay.
So let me make sure I'm getting this right.
Go ahead.
So what you want is you want 2 decimal places so it can be in the 10th place.
Well,
THS.
Well, the 5 and the 4, that's tenths and hundreds, right?
Yeah.
So all we're worried about, you can have as many decimal places as you want.
Mhm.
So I could even add more zeros if I wanted to, but no matter what, that number would still be between 1 and 10, right? Is 3.54 between 1 and 10?
Yes.
Yes. So that's what we're looking for.
Oh,
Professor, I have a question.
What's up?
I'm still kind of confused. Like, how do you know when to stop? Because we could have stopped between the 5 and the 4.
If I stop between 5 and the 4, what number would that give me?
35.
Oh,
So it'd be over the
35.
10.
35.4, which is greater than that 10.
Got it. Thank
Good
you.
question. No, good question. Okay, so let's go ahead and try the other number. All right. So I'm going to take this decimal and we're going to move it to the right until we get a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Do I stop there? Or do I keep going?
You can
Yes.
stop there.
I stop there, right? Because that would leave me with 9.876 times 10, and we moved it over how many spaces?
9. So it'd be 10 to the 9th power.
It's going to be negative though.
Oh, okay, because you're moving the opposite way.
Exactly. And remember, the reason it's negative is because if we have to convert this number back to its original decimal number, if we have to go from scientific back to decimal, then we would take that 9.876. And since that negative 9 says move to the left, we would take this decimal, move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left and fill in all those zeros. I guess we can explore on that more, right? If it's a positive n, that means you're going to the right. And if it's a negative n, a negative number, negative exponent, then you're moving to the left. All right. We good with those two? We see those thumbs. Who's alive? 2, 3. There we go. All right. Okay, cool. All right. So the next two examples is just going the opposite way. We're going to go from scientific notation to decimal notation. So for this example, we have 10.32 times 10 to the 6. That is a positive 6, which means how many spaces to the right are we going to move that decimal?
6.
So 1, 2, 3, 4, 5, 6. And all those little humps there, you're going to fill them in with what?
Zeros.
Zeros. And that is that 2 million? Yeah. 2,320,000. All right. Next one. 5.2 times 10 to the negative 3. Which way are we going to move that decimal?
To the left.
To the left. How many spaces?
3.
3. 1, 2, 3. There it is. 0, 0. And we get 0.0052. All right. And that's scientific notation. If you're going from decimal to scientific, remember that whenever you move the decimal, you have to move it till you get a number that is between 1 and 10. So we had 3.54 and 9.876. So both numbers are between 1 and 10. All right. All good? All right. Okay. Next is metric measurements. All right, so I guess this is a little fun activity. Fill in the table with real life examples of the following measurements and add more answers. All right, so we just want to know, where would you see these measurements in real life? Any examples? So the first one is 1 meter. What is a good example for 1 meter? Where would you see that?
Racetrack.
Racetrack, good. On a race, right? You do like the 100-meter dash or something. All right, that's good. All right, then next example. Where would you see 1 centimeter?
A ruler.
A ruler, good. A ruler. And what about 1 millimeter?
Crochet needle.
Really? Crochet needle. I like that. No idea about that one. All right. Anybody know what this one is? If you look on the next page, you'll know what it is. But if you've never seen it before, because you probably haven't, it is 1 hectometer.
Okay.
1 hectometer. And I would advise you to Google this one, just so you know what a hectometer is. Somebody Google it and tell me what it means. Shoot, I'll Google it too. A hectometer
100
equals
meters.
100 meters. Good. So a hectometer is equal to 100 meters. So what would that be used on? Let's see what this definition. Go Wikipedia. A football pitch is approximately 1 hectometer. Cool. All right. A football pitch. Of course, soccer, meaning football. All right. We'll just say soccer. Why not? Okay. What about 1 gram? Where would you see that at?
A scale?
Like a alternate weight on food packaging.
There you go. Scale. Food packaging. Love it. Love the answers. For those of you alive out there. All right. What about 1 kilogram?
All I can think of is like weightlifting.
Okay. Cool. I'm in. Weightlifting. You know, it's probably not an appropriate answer, but I've been watching How to Catch, what is it? How to Catch a Smuggler or something, where they catch all the people at the airports with kilos of cocaine and they use a scale. Look at that. So it's a fun show to watch. All right. What do you think about this one? This is 1 microgram. Where would you think you'd see a microgram?
I was thinking maybe with pharmaceutical companies.
Okay. Pharmaceutical. I don't even know how to spell
Or you
it.
could just put medicine, because I actually have some that are micrograms.
Really?
Mm-hmm.
Cool. I like it. All right. How about this guy? 1 liter. Where would you see that?
Sodas.
Sodas. All right. Oh yeah, they do sell sodas in a liter. I'll have a liter of cola. All right. What about 1 milliliter?
This could also be like medicine or like a syringe.
Okay, like Tylenol or something, right? Or no, like NyQuil, something like that, right?
Like a liter of Coke.
A liter. We don't have a liter of Coke. All
Yeah,
right.
they do the 1 liters at HEB.
All right. Good. What about square centimeters and square meters? Where would you think you'd see those? Whenever a unit of measurement is squared, what are you usually looking at?
Like dimensions or square footage or something like
Good.
that.
Yeah.
Maybe construction.
Dimensions, construction, both of these answers go together. Dimensions, construction. When you buy a house or you rent an apartment, they say, and I don't really care about it, but my wife did. They're like, hey, this is 2,000 square feet. And they get all crazy. And I'm like, can I fit a bed in there? I'm like, yeah, sure. So, good.
So this is bringing back some memories, and I don't know if we're gonna get into it. Is this that King Henry died?
Drinking chocolate milk.
Yeah, there you
Poor
go.
guy. Poor guy. And that is correct. Look at that. King Henry died drinking chocolate milk. The only things you're missing is micrograms and megagrams, or mega and micro as your unit. There you go. Bringing back some memories. Look at that. Okay. Those were all good examples of where you find these in the real world. All right. All right. The leader of Cola Super Troopers? Anybody? Maybe? All right.
That was exactly what I was going for.
There you go. All right. So on this next page, we just want to do some metric system conversions. So whatever we're given, we will use this prefix chart above to help us convert from one unit to another. And it's as simple as moving the decimal place. So if we look at number 5, it says 50 centimeters. So we want to go from 50 centimeters to meters. So what you would do is reference the chart. You would find where centi is. So here is centi, and you would find where meters is. So on this middle part, here's your basic units: meters, grams, liters. So we want to go from centi to meters. So how many spaces over is meters from centi?
3.
2 to the left.
It's just 2 spaces, right?
Yeah.
So-
I'm fired. Yeah.
You're good. You're good. So what you would do is you would take 50, put a decimal on it, and take that decimal place. And since it's 2 spaces to the left, you would take that decimal and move it to the left 2 spaces. So this means that 50 centimeters is how many meters?
.5 meters.
Good. 0.5 meters. There it is. That's all you have to do. And you referencing that chart makes it beautiful, easy. All right, let's do it again. So 8 kilograms to grams. So just write 8.0 there, and you find kilograms, and you're going to grams. How many spaces over are we?
3 to the right.
3 to the right. 1, 2, 3. Take that decimal, do the same thing. 1, 2, 3. Fill in those with zeros, and we get 8,000 grams. Not bad, right? Okay. Do it again. 9.1 kiloliters. 9.1 kiloliters. So let's look at that. We're at kiloliters and we want to go to liters. All right. So this is just like number 6. How many spaces over are we?
3.
3. 1, 2, 3. 3 to the right. 1, 2, 3. And we get 9,100 liters. Okay. And then number 8. We have 0.098 grams, and we want to go to milligrams. All right. So we're at grams, and we want to go to milligrams. So I'll write this out. 0.098. And how many places are we moving that decimal over?
3.
3 to the left.
3. 1, 2, 3, right? We're going from grams to milligrams. So we will get 98 milligrams. All right. Everybody good so far? See if I can zoom out on this a bit. All right. See, not bad. Nothing crazy yet, right? All right. And do it again. 9.1 milliliters to liters this time. So 9.1 milliliters to liters. There we go. All right. So I have 9.1. And now how many decimal places am I going to move that?
Three to the
3 to the left. So 1, 2, 3. So 0, 0, and we get 0.0091 liters. E. That's it. Okay, keep it going. Okay, and then here to blue, 0.72 kilometers to millimeters. All right. Kilometers to millimeters. Oh boy. How many spaces are we moving that decimal?
6 to the right.
6 to the right. 1, 2, 3, 4, 5, 6. What's that? 720,000? Millimeters. Okay. Awesome. All right. And then 11.568 kilograms to milligrams. All right. Well, we just did something similar, right? We just said from kilo to millo, and that was how many spaces?
6.
6. 1, 2, 3, 4, 5, 6. So 568,000 milligrams. Okay. And then grams to micrograms. So we have 0.98 grams, 0.098 grams to not micrograms, right? So here's grams, here's micro, and 3, 4, right? 1, 2, 3, 4. So 0.098 and go 1, 2, 3, 4. 980 micrograms. All right. Zooming out there, and next 2,000 milligrams to micrograms. Ah, you only move how many spaces over?
1.
Just one, right? So you just move one over, and we have 20,000 micrograms. Okay, cool. All right, next, 4 square meters to square centimeters. What do you think we do here? We want to go from 4 square meters to 4 square centimeters. So what would the operation be here?
Two to the right.
2 to the right would be from meters to centimeters. We want to do square meters to square centimeters.
Oops.
You're close. We would do 2 to the right, and then we would again do what? Because moving over twice would be 4 meters to centimeters. Moving over 2 more times would be for what? So
Square.
I was thinking semi square.
2, 3, 4, right? 1, 2, 3, 4. And you would get that 4 square meters is 40,000 square centimeters. Okay. So whatever that power is, right? You're gonna have to do it twice. So if from meters to centimeters, you do it once. For square meters to square centimeters, you do it twice. And if it was cubed, if it was cubic meters to cubic centimeters, how many times would you have to do it over?
4 times?
3 times,
3. Oops.
right? The power gives it away, right? Okay, don't worry. That's the next example. Let me see. Zoom out again. There we go. And this one says we have 0.00025 hectometers, cubic hectometers to cubic centimeters. So we're going from hecto to centi. And how many times are we gonna have to repeat the process?
3.
3 times. So this means we're gonna move the decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're gonna move that decimal over 12 spaces. Here, I'll write this out. 0.00025, and we're gonna move it out 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then 0, 0, 0, 0, 0. Ooh, what number is that? Is that 250 million, right? 250 million. Cut that off and that off and that off. All right, perfect. Yeah. All right, cool. There it is. Okay. 16. England is 130.4 billion square meters. Convert this to square kilometers. Okay. So for this one, get rid of that. We want to go from meters. So we're going to go from meters to kilometers, right? Okay. And if it's square meters to square kilometers, how many times are going to repeat the process?
Twice.
Twice. So you would go 1, 2, 3, 4, 5, 6. So 6. Okay, but we need to write this number out. 130.4 billion. All right. So in order to do this, we actually need to write 130.4 out. So it's going to be 130 billion 400 million. I think I need 3 more zeros. Yeah, because this would be million, and then add that on, that would be billion. Okay. So we have written out 130.4 billion. Now we're going to take that decimal and move it over 6 places. 1, 2, 3, 4, 5, 6. And for our answer, you're going to get that 130.4 square meters is equal to 130,400 square kilometers. That's what we're looking for. Okay, not bad. And that was metric system conversion. So if you follow that table, you should be just fine. So any questions on that page?
Can you zoom in so I can take a picture of that table?
Yeah, it should be on the notes though. On your set of notes, but if you want to take a picture of it, that's fine.
I'm good, thank you.
Yeah, for sure. Okay, everybody good with these notes? Okay, cool. Maybe we can jump into these notes then. What do we have? Ooh, we got a lot. Sure, let's see how far we can get. Okay, I'm gonna stop recording on this one.